Mình là Huy. Tụi mình Rocking là một tổ chức mình thành lập phi lợi nhuận để mục tiêu là tập hợp các bạn hay là mong những cái chương trình về software engineering chất lượng cho các bạn. Ví dụ như đây là cái buổi nói chuyện, cái buổi Rocking Tech Talk này là cái buổi mà Tech Talk tụi mình tổ chức hàng tháng với mỗi tháng là một chủ đề khác nhau để mà giới thiệu những cái kiến thức hay những kỹ thuật mới cho của industry cho các bạn biết. Thì ví dụ như thế này, lần này mình làm tới lần thứ 12 rồi, và cái tháng trước là cũng tổ chức tại đây luôn, là nói về data, còn lần này thì tụi mình nói về programming language paradigm. Ok. Thì ví dụ như những trước đây tụi mình là có nhiều cái talk khác nhau rồi. Ví dụ như trước đây là tụi mình nói về nhiều chủ đề khác nhau. Ví dụ như là nói về infrastructure, nói về microservice, mình nói về Redis, mình nói về data infrastructure hay là những tech stack khác nhau của những công ty khác nhau. Tụi mình nói MongoDB cũng đã từng nói rồi, Flux architecture cũng đã từng nói rồi. Nói chung là những cái gì mà thiên về công nghệ và kỹ thuật, nói chung là lập trình kỹ thuật, công nghệ, computer science, algorithm là những thứ mà tụi mình muốn tập trung để mà cover ở đây. Sẽ không có những cái về business hay là những cái về make money. Ok. Ngoài ra thì mình có một cái cộng đồng Slack để mà mọi người tới thảo luận về những cái những chủ đề technical. Thì nếu bạn nào chưa tham gia thì mời bạn lên tham gia tụi mình ở đây. Ok. Rồi. Tụi mình ngoài ra thì tụi mình có partner với một community partner là có maintain một cái trang job board thì khá là high quality job board. Cho nên những bạn nào muốn kiếm cơ hội thì hay là những anh chị nào ở đây đại diện công ty tới có thể lên đây để mà đăng tuyển việc hay là cho cộng đồng của mình đăng tuyển thì hoàn toàn là miễn phí, và các bạn có lên đây, các bạn liên hệ, bạn nào muốn kiếm việc thì lên đây liên hệ trực tiếp với mọi người. Ok. Chương trình hôm nay thì rất là đơn giản, chúng ta sẽ có 3 bài talk. Bài đầu tiên là nói về full stack Scala web application của một bạn Cuong từ Anduin Transactions. Talk thứ hai là nói là một anh của anh Nguyên đến từ Equino, và talk thứ ba là của anh Harley đến từ Coder School. Ok. Ok. Trước khi mình qua chương trình chính thì muốn hỏi là gần đây có hai tin rất là vui cho đồng lập trình. Thì không biết các bạn nào biết không, một cái là tin của thế giới và một cái là tin ở Việt Nam. Bạn nào biết cái này? Đúng rồi. Tin đầu tiên là các bạn nào là trình viên kỷ lục cao thì được giảm 5% thuế thu nhập cá nhân. Nếu bạn nào chưa biết tin này thì mời các bạn lên mạng Google. Rồi tin thứ hai. Đúng rồi. Tin thứ hai là Oracle kiện Google về việc dùng Java trong cái Android, hệ điều hành Android của họ, và sau mà 4-5 năm trời thì cuối cùng là Google thắng chuyện này. Ok. Bạn nào có nhận định gì về hai cái tin này không? Các bạn nào có nghĩ gì không? Ok, các bạn nào có ý kiến khác về chuyện này? Đúng không? Nhưng là làm công nghệ mà có công ty không biết gì có đúng không ạ? Ok, nếu mà có gì thì tiếp tục. Ok. Rồi bây giờ bắt đầu qua chương trình thì mình mời anh Cường bên Anduin là sẽ nói về bài đầu tiên này.
Hey, hi everyone. I'm Cuong Pham from Anduin. This is also my first time at a Rocking meetup. So I'm very excited to be here today to share with you guys some of the experiences that we get from using Scala to build our web app application. An earlier version of this talk has been given by our Director of Engineering. It was at a Rocking meetup in Singapore. But we think that since it was in Singapore, so the crowd was different. So we hopefully that the overlap between the two crowds are not significant. And secondly, we think this topic is very relevant to the topic of the meetup today, which is about programming language and paradigms. So today we talk about Scala. So first, a little bit about myself. So I've been with Anduin for about over a year. So I started as a remote part-time, and I recently came back here to join the team at Ho Chi Minh City. So prior to Anduin, I spent about 2 years at Armor Computing, a tiny startup in the US, at which I mostly hacking Linux kernel. And after that, I decided to go to grad school. So I went to University of Illinois, Urbana-Champaign. And during my time at Illinois, I interned several times at IBM Research, where I involved in several projects in cloud computing. And so I'm broadly interested in operating systems, virtual machines, hardware, and can you guys hear me? It's a little bit weird. And system reliability and security. So please come talk to me if you're interested in any of these areas. So for the rest of the talk, so firstly, I spent some time to talk about Anduin, about the product that we're building, so that you can put what I'm going to talk about in perspective. Right? And then the main part of the talk, I talk about how we use Scala to build both backend and frontend, and some of the advantages, disadvantages. This is like that. So I talk about some advantages of the approach, disadvantages, and then I conclude with some lessons that we learned during the process of building our product. So first, about Anduin. So Anduin's mission is to become the standard for executing private financial transactions through the use of smart technologies. And we want to be the standard because there's no such a standard out there. So everything is very ad hoc, everything is very old school. People just using email and spreadsheet, doing this kind of stuff. So, secondly, anytime you want to get in the middle of multiple parties with conflicting interests, it's a guaranteed trouble. So it's not easy doing this. So as a consequence, it's usually extremely difficult for us to get a complete picture of how such a transaction works. When you talk to customer, each one gives you a different way of executing this kind of transaction. So because the process that they use are optimized for their own interest, right? So, and lastly, it's the kind of legal information and financial information that we have to deal with is extremely sensitive in terms of privacy, security. So that's why we need to build a platform that is secure, reliable, and also need to be flexible enough for us to adapt with all different kind of changes in this environment. So it's and about the team. So right now we have 9 full-time engineers, 1 intern, and as you can see here, the range of educational background is very wide. We have like 2 guys, like it's actually like that's like 2 boys that drop out of college and they're still working for us, and we have PhD from top American universities. So we also have people with experience at American technology companies such as Palantir, Facebook, Google, Amazon, IBM. And besides that, we have 3 product designers and 3 ops and 3 legal or product people. So we have 2 offices, 1 here in Ho Chi Minh City and 1 in San Francisco. So that's enough about Anduin. So at least you have some sense of what we are, so you can put what I'm going to talk about in perspective. Yes, please.
Could you explain more about the private financial transaction, what it is, give us some examples?
Right, so the question is here asking about the privacy of the information, the financial information that we have to deal with. Right, so I'm just giving you an example. Is so one kind of transaction we're dealing with is what we call primary funding transaction, which is VC trying to invest into a company. So all different. So some of that information is published, but most of them are not published. For example, like how much of the stock that they get from the company. Basically, there's some kind of like cap table that they have to manage. It's extremely sensitive information, and like any legal information is also sensitive. Only like lawyers, they know about that, and like the party that directly deal with them know about that, and external parties shouldn't know about that. So that kind of sensitivity that we have to deal with.
Okay.
So this is the stack that we're using. So as I mentioned before, we're using Scala for building both backend and frontend. So building a web app using Scala, usually people use Scala for backend, but using Scala for frontend is, we believe, is new, and I'll show you why. And for automating resource allocation in AWS, we use Terraform and Ansible. And we use Jenkins and GoCD for automated building and testing. And we heavily use Docker for local development environment and also for testing. And we use Kubernetes for automated continuous deployment. So the main part of the talk, I focus on the first bullet point, which is how we use Scala in our environment. So this is our the overview about architecture. So we're building a web app, so we're serving the browser on top. In the front end, we generated view using HTML and so the view basically are HTML and JavaScript code, right? And but the JavaScript code is generated from Scala. I'll show you later how. And in the backend, we use Scala, and it's Scala is Arca HTTP-based actor backend, and the model is shared between backend and frontend, and it's how our database represented and persisted. So basically, the front end we have we have view and API and the model which is written in Scala.js. And with Scala.js, it will be compiled down to JavaScript, and the JavaScript file that compiled will be served to the client, which is the browser. In the backend, we use Scala, which is compiled into Java bytecode, and at runtime is executed on top of JVM. So with this model, our code base is basically Scala. It's just a different way to compile it. So for the backend, we use Scala C to compile down to Java bytecode, and in the front end, we use a compiler plugin to Java C to compile down to JavaScript. So basically, the entire stack code base is Scala. And the benefit of it, you can see here, at least we have a large portion of code share between the backend and front end, which is our model there. And particularly for the front end, we use React, Facebook client to library to build our front end. So a little bit about, so like I mentioned, using Scala to build backend is very common, but using Scala to build front end is new. And the reason that we could do that is because we have Scala.js, which is recently released and used, and we are one of the first company that use Scala.js in production that we are aware of. So this is what we get from the front page of Scala.js. So basically, Scala.js is Scala. It inherits all the good thing about Scala. Particularly the strong typing system that we can utilize from Scala, we can use in Scala.js, and performance, since it's used latest compiler technique to clean JavaScript code generated by Scala.js, so it ensures the performance of the web app, and especially using Java.js, it's very easy for you to integrate existing JavaScript libraries. So all available JavaScript library we can use. So this is how Java.js is generated. So basically, Java.js, like I said, is Scala. So on top here, so on top of the picture here, basically you write normal Scala code. Normally, Java code will be compiled by Java C down to Java classes files. So you could execute this on top of JVM. That's the normal compilation process for Scala. For Scala.js, it basically a plugin built into the Scala compiler, so that it compiles this Scala code into a different intermediate representation, which is this format. And from this format, you could use different optimizers, basically provide you different output. It's still JavaScript, but different quality. For example, in development, usually we prefer fast compile time, right? So we could use fast optimization, which give you, which provide you probably like a pretty big JavaScript file, but it compiles very fast. But for production, they use Google Closure compiler, which do a lot of optimization on top of your JavaScript code, so you can get pretty optimized JavaScript code. So this is the compilation process of Scala.js. So again, why because basically it can combine most Scala code. There's some exception, for example, reflection, which is particularly generated for JVM. And since we're not using JVM runtime, so we cannot use any reflection here. But basically, we can use most libraries that developers love in Java, in Scala.js. And also, developer loves like great IDE support, right? So basically, you can refactor your code very easily and fast. The IDE can autocomplete and correct your code, and it catches most of errors in like while you're typing. So basically, if your IDE says that your code is good, then you can just compile and run it. And also I mentioned that it's very easy to integrate existing JavaScript libraries into a Java.js program. So that's the reason that many people like to use Java.js, because you can take advantage of all previous development of JavaScript libraries and use latest and state-of-the-art compiler techniques. Java.js can provide you very optimized JavaScript output, and it inherits all good points, like all advantages of JavaScript. For example, in here, it takes full advantage of asynchronous computation model that JavaScript prefers. And with Java.js, we can use Facebook React.js, Angular.js, D3.js, and all different kind of JavaScript libraries. So this is a more detailed how Java's Scala.js is used in our system. So like I mentioned before, for development, the Java Scala.js output is automatically used for testing our system right in the browser without any extra compilation process. And for production, we take advantage. Well, the Java.js compiler take advantage of Google Closure compiler to optimize the JavaScript here. So, and they use linker to link with existing JavaScript dependencies. Or it's also very easy for you to write your own library and export it to JavaScript. And like I mentioned, we are proud to be one of the first companies that publicly use Java.js for our production system. And the first comment here is from Bing Wen, our CTO or director of engineer. So basically, everyone that we've seen decided to move to JavaScript or happy with the decision. So that's one more example of the advantage of, like specific example of the advantage of using Scala and Scala.js is everything is type safe. In here we can write basically type safe REST API. So on top here you can see that the interface of the API that we want to export. Basically, the front end, the back end share the same interface. So a call from front end to back end is basically look like a normal call. If you know the RPC remote procedure call, it's basically this. And TypeScript, every Scala developer loves TypeScript. So using Scala, we see a lot of advantage in this. First, we can keep the quality of our code base very high. So it's the combination of using Scala best practices and code review. So even Scala is a complex language, but we see no difficulty in making new people run off with the current process. So later I show you, even our designers love writing Scala code. We have a bunch of interns, they all contributed to our code base after like 1 week, at most. And most importantly, as I mentioned, we needed a platform that allows us to adopt, to react to changes of the requirement very quickly. So this is what we achieved from using Scala and Scala.js in our system. And several things that we benefited from using this is, so behind all the libraries, all the concept principles that Scala and Scala.js use have a rigorous theory behind it. For example, category theories is one example. Everyone knows this stuff when you can use this kind of applicative monad-free structure in your program and make your program very rigorous and very safe. And type class help you to detect error right at compile time. So basically, you can encode business logic of your class, of your object classes into the definition of the class, so that the compiler can check errors for you. So basically, you shift time from testing to compile time. So it's an advantage of using Scala in general and a strong typing language. And also I mentioned code sharing is great. And no one likes to write redundant code, redundant logic in 2 different languages. And among the right design of the system, around it is a very awesome community, I can say. They are the smartest people that I work with. Also, they are very responsive, very responsible for whatever they do. So we're using a lot of open source library, and we can just talk to them directly to get their support, to get their feedback to our design. So it's one of the things that I love about this community. And so that's about the advantages, and of course we have to pay cost to have this kind of advantages. So one of the criticisms for Scala is there's so many ways to do one thing. That it's a language combining of object-oriented principles and functional programming. So you could write pure functional program, or you could write just pure object-oriented program, and it's still fine in Scala. And the thing that we hate the most about this environment is compile time. So basically, you have to pay the cost for compiler to check your logic before. So it's a trade-off. Instead of you pay time for running your test, so now you have to pay time for spend time for the compiler to compile your code. Of course, there's still still many optimizations that we can make in our system, but it's the inherent problem for any strong typing compiler we use. But basically, it's the trade-off that we're willing to pay. So basically, if we can compile the code, we have a high level of confidence that the code will run. So a lot of runtime the trade-off that we're willing to take in this case. And to be honest, it's a complicated language. We learn new things every day. But since we are people who love challenges, it just like excites us. It's one way it challenges, but the other way it just like make us like it's more fun working with this system. And behind it, there's a bunch of theory that we need to know in order to master this technique. And it can be scary sometimes when look at it like developer math. We cannot even like do good like basic calculation. Now you show me a bunch of like theories, and it's scary sometimes. And more scary things about Scala. Like more and more scary things. It's just like challenging us. But like I told you, people love challenges, and you would be amazed by just giving them challenge and giving them things that they need to try hard to do. So even here, we thought at the beginning we didn't expect our designer to like touch Scala code, but somehow they just love doing it. So it's an example of the code written by one of our designers. More code written out designer, and I told you that sometimes we just be amazed by like how much they could do with the system. So lesson learned. Investing in tooling is it's basically investing on the productivity of your tool, of your team, basically. So we spend a lot of time building our system, building our environment, the dev environment, because we care about productivity a lot, as you all do, right? So then we use system. Well, we use some system that are integrated with our GitHub repository to do testing automatically, for example. And we use some system that automatically check coding styling for us, so that it reduces the code review time significantly. Also, more tooling we use. So what we like about Scala community is they all like high quality code, so they also invested a lot of effort on building tools that help them to maintain the high quality without a lot of effort. So we take advantage of that effort also. So, and learning, because it's such a complex language and such a complex environment to work with, so we also always encourage our people to invest in learning. And we do also like internal tech talk that we train ourselves. And we're building a libraries so that everyone who is interested in any books can make a request. And also we try to be a part of the awesome community, the Scala community, Scala.js community, and also this blogging community. I know that when our CTO is a very frequent speaker for in this meetup, so he's given talk about microservices and some other topics. For example, last time we went to Singapore to give the talk, and because we care about code quality, code review is required for us.